Hello there. In this video we're going to evaluate some trig expressions and figure out where they are in a graph. So we'll start with this top one, 10 sine 60. Now the 10 there, that actually is telling me what the radius of the circle is, so I need a big circle, radius 10. Alright, and 60 degrees, now there is an important relationship here of 60 degrees. That's going to take us actually to the 1/2 root 3 over 2 location. So if we'll recall here, so there's going to be a 10 out in front, the sine of 60 degrees, that's its elevation, so that's actually going to be the y-coordinate, which would be this one, so that's all the way up here in the graph to that location, and that's root 3 over 2. And then multiplying through, we can get that this is exactly 5 square roots of 3. And let's keep it in that exact form, don't need to convert that to 8.66. Okay, onto the cosine one. It's actually reflected over to the other side, so it's going to have the same height, but this time we're interested in the cosine, and that is the, if we sketch that in, that is going to be the x displacement. So this is 10 times the cosine of 120. Familiar with our 30, 60, 90 triangles, that is negative 1/2. So we can see here that that is going to be a value of negative 5. Alright, next ones. Our circle shrinking. Alright, so there's a rough sketch of our circle of radius 8, and 130 degrees, that's going to be a bit past that 120 there. Again, this is going to have to do with the x displacement, so we're figuring out this distance down here. Now this one, 130, that's not a multiple of 45 or 30, so this one we'll just evaluate in our calculator. Multiply through there and you get what our value is, and that is our horizontal displacement on that whole thing. Okay, 8 cosine 230. Now interestingly enough, that 230 degrees, that is actually perfectly below the 130 degrees. And there's a relationship here that the 130 is actually 50 less than 180, and the 230 is 50 more than 280. So they're going to, and when you flatten them out, they're going to have the same horizontal displacement. Those cosine values are the same. And that's kind of a neat thing there. I'm making a big mess here. Same because they have the same horizontal displacement. That cosine, remember, as a definition, is x over r, and both this point and this point have the same x-coordinate. Alright, last one involves a small circle, radius 3. 225 degrees is going to be right down there, so we're getting that location there. Should actually be a bit underneath the other one, because that has to be 45 past, and that one's got to be 50 past. But I'm not sure how well that's coming across in my drawing. Okay, sine has to do with the y displacement. And I recognize this as being part of the 45, 45, 90 triangle. It's actually 45 degrees past that 180. So I know that ratio is negative root 2 over 2. And we get an exact value of negative 3 root 2, whoops, all over 2. Okay, and then on the other side, 315 degrees, all the way over here, that's 315. So again, we're going to have the 3. Now we're taking a sine, so that has to do with the y displacement. Sine, remember, is y over r. Once again, this is negative root 2 over 2. So once again, we're getting the exact same thing, and that's not all that surprising, because those two angles have the exact same y-coordinates for that point and that point over there. Okay, thanks for watching. Character and Scholarship for Life.